Hey there, flyers. Welcome back. This episode is brought to you by the 69th Drone Detachment Airborne. And today we're going to talk a little bit more about the good old DJI Air Unit. DJI ain't talking. I don't know why, because, no one can manufacture this. They could give this stuff away. They could give us the schematics, and someone else ain't going to run out and be able to do it, because they got their own chipsets and burners and MIMO and everything else, so probably, could give a hoot if anyone knew, but they're just holding it close to the vest. We'll do a real quick review. Got your little air unit here. I'm kind of drawing around this camera, so I'm not drawing as good. Basically, what it's got is a DVR. I'll just call it a DVR. And it's got a little SC or SD card. Some people call them TF cards. That was what they're called at first. Going out to USB slot. And then it's got in here somewhere, it's got a vTX, video transmitter. And it's going out to an antenna. Oh, but what do you know? It's also got a little receiver to receive the radio control signals. Kind of messing that up. We'll go a loop over there, boom, and down to the flight controller. So there's the air unit. It's got two antennas. There's not one dedicated to transmit, one to receive. They both share both antennas, both the radio control link, both the video feed going back, and the telemetry feed going back. So basically you almost got three things sharing this. Now if you're flying with a Taranis, you're not using this function here. But if you're flying with a DJI radio, they're doing them all on the same thing. So I don't like just black boxes. A vTX, what are you talking about? It's crazy. But I used to be, electronic tech and engineer, and I worked on some big satellite and radar stuff that these components were discrete, and you had to troubleshoot them down to the component level. But it don't matter if it's in a real small chip or not, you got the same things. So let's just talk about the vTX for now. That vTX, you're going to have coming in here some CMOS data off your camera. It's just digital video. So, right away, you're going to have some kind of signal processing, to get to the right logic levels. An I/O function, interface, input-output function. Even though it's digital data, you still may want to filter it, make it nice and clean and crisp. But coming out of there, what's going to happen next? We got to go to some kind of a modulator. And really, before we do that, we might even hit an encoder. Because they may like to encrypt their data, spread spectrum, modulate it, mix it with a pseudo-random bit sequence coming in this way. They might want to do some kind of encoding, encryption, who knows what. But usually the data will be fully processed, then it'll hit the modulator, which in this case, I believe is pretty much a QA, it's a quadratary amplitude modulation modulator that's then spread. It's then spread spectrum, which is then frequency hopping as well. So there's all those circuits are kind of in there to some degree. Coming out of that modulator, you're going to have to go. I might have to move over a little here to keep this in the center of the picture. Tap old GoPro and see how it looks. Yep, we'll move over a little. Now you got a signal modulated onto an RF carrier. Phase and amplitude changes for every 1 and 0 change that comes in here, or combinations thereof. After this modulator, you got to go to some kind of an up converter, maybe a block up converter that does it in one stage. Takes a local oscillator signal, puts it into a mixer, and that you get this low level IF, intermediate frequency modulated signal, mixed with an RF carrier from that oscillator. It's an LO signal, they usually call it, or RF LO, radio frequency. Coming out there, you got the sum, the difference, and two original signals. You just filter, so you take the sum, since you're up converting, put it through a filter, and coming out the end is what? A higher level 5 gig RF signal that can then be coupled into a PA a linear power amplifier, and we'd call it a HPA. You know, it only gets up to 1 watt, maybe 1.1 watts, 1100 milliwatts. And then it couples on out to the antenna. And at that point, the current varying across that antenna and changing that quick is going to result in the correspondent magnetic field that collapses and raises. So you've got an E field, an electric field, and an H field. And thus your RF. Zooming on out to go back and amaze you with the video. So that's basically the uplink chain. It may be all in one chip or 2 chips. This may be one chip here. This may be a separate chip. This could all be MIMO, you know, or like multi-miniaturized integrated circuit that's got all those RF components on it. We don't know. But we do know, coming in the other way, okay, you guys, the Taranis guys may not care about this part, but regardless, your receiver you're using for Taranis is going to do the same thing. You're coming in with your radio controlled signal to an LNA, a low noise amplifier, which will amplify the signal but not the noise. Then you're going to have to come to a block down converter this time. I'm just going to let myself get sloppier so I don't got to worry so much. Same thing, it takes an oscillator, puts it through a mixer. Coming out of there is the sum, the difference, and the 2 original signals. This time we filter for the difference. And now you've got an IF. The low frequency is still modulated though, but now it's intermediate frequency. And that may not go like on a cable or across to a rack like it used to go. It may be just one part of the chip to another for all we know. But we know it's doing that function. It's got to convert it down from 5.1, 5.8 gig down to a manageable frequency before you demodulate it. Taking in the demod, and that it's using the same type of modulation scheme. QAM, it unspreads the signal if it's spread spectrum, it unhops it, gets a stable carrier, and then demodulates it. And now coming out of there, you got data. Could be NRZ, could be bipolar, it could be just single phase, single direction NRZ. But in either way, it comes in through. It goes into that encoder again. We're going to move over. Boom. That encoder may change it from one type of data format at the input to a different type of the output, either logic levels or, the way they sense data. And then coming out of that encoder, you probably got a same, like the reverse of this, some other kind of signal processor, interface board, maybe some filters, and there go your data bits marching out there, going to the controller, saying, oh yeah, here's a command, turn left, whatever. And basically that is the vTX chain right there. And that's the receiver for the DJI FPV radio controller. And the only other one we got's a DVR. I mean, I guess I could do a block diagram of DVR. I don't know that one off my head that good because I worked on this equipment a lot. And I'm intimate with it. The DVRs, I mean, I tried to fix my one at home, but not professionally. Maybe I will. If you're interested in it, we'll do a DVR block. But that's the basic whole block diagram of the DJI Air Unit. And maybe they ain't talking exactly what kind of modulation it is, what kind of encoding. If it's a single stage or a dual stage up conversion, or maybe they just go straight to modulating right at the S-band or C-band up there at 5.8 gigahertz. We don't know. That's proprietary. But we know these are the functions that happen. And these could be parts of a chip or separate chips. It could all be on one monolithic chip once we get smart enough, who knows. But now it's no longer just a vTX and you don't know what it is. The only difference here for the analog FPV guys is instead of the CMOS, they'd take CCD analog video coming in, basically coded NTSC and PAL. It's not pure analog, it's got frames in it. But they'd need a A to D converter to basically convert that into digital data and then encode it and then modulate it and whatever. So they've got an extra phase. That's the extra amount of delay. Just encoding that, processing it, sending it over. It's, down in the nanoseconds or something, but it adds up. Every nanosecond adds up. So anyhow, this is any kind of two-way radio system in a drone. And so now it's not just some picture. And anyhow, hope y'all are having a great time flying. I'm uploading some nonsense. I need to get my flight controller right. And it's a great day and I'm missing it, so I thought I'd draw this for you. We'll see you up there in the skies now. Y'all keep on flying. Once again, this was brought to you by the 69th Drone Detachment. Airborne. Bye now.